and to identify the intruder. Okay, so for intruder detection we are using, then for assembly verification, for screen reader, and for code and character reader, and also for this robotics for bin picking. Okay, so for these are some of the applications, but the list goes beyond. Okay, so a number of applications are there where you can apply this computer vision. Okay, and when you see this, okay, when you that is when you take this computer vision, there are different types of computer vision as well. That is, when you talk about computer vision, that means how the machine or the system computer view things. Okay, so under that we have image segmentation. So how it identifies these segments, then object detection, facial recognition, edge detection, pattern detection, image classification, then feature matching. So all these things comes under different types of computer vision. Okay. So sometimes you may wanted to find the image segmentation. See, for example, you just take some medical application. Okay, take some medical application. You take some image. Okay, whether it may be an MRI image, a CT image. Assume that it may be a brain CT. Okay, you wanted to classify that into, okay, some that is whether it has some tumor or not. Okay, non-tumorous. Okay, in that case, what you have to do is you have to segment. Okay, where the particular tumor occurs. Okay, so here the segmentation is very important. So it gives a view. Normally, the technologist, okay, the radiologist or the expert, okay, the doctors can see where exactly that tumor lies. So, but now when you see the imaging modalities, they itself, okay, so that it actually segments and it shows where actually that problem exists. Okay, so that it will be easy for the doctors to identify where it exists. Okay, and similarly, object deduction. Okay, the second application, object deduction. Okay, so for example, nowadays so many, when you talk about this smart city applications, okay, and if you wanted to, or smart transportation, you wanted to identify the objects, okay, what object is moving, okay, and all those things. In that case, also this computer vision plays a vital role, okay, major role. Whether it is a two-wheeler or a four-wheeler, what object it is, okay. So that type of things. And facial recognition, as you all know that it has a wide range of application again. Now it is very common that using that only you are logging in, right? And edge detection. So that is also somewhat similar to your image segmentation. Okay, well, that is to identify the appropriate edges. Okay, that sharp parts in the image to identify or to detect the shape, etc. Okay. Then pattern detection. See, for example, you wanted to find out whether that exact pattern is available in that image or not. So this pattern detection is applied in so many applications. Okay. For example, again, in your medical imaging, it can be used. Okay. Or in case of that is retrieval. Okay, content-based image retrieval. So in that also, this pattern detection is used, as well as image classification. So image classification is you wanted to classify that image into cat or a dog or a flower, whatever it is. Okay, so you wanted to classify those images. So for that also, you are using this computer vision only. Similarly, feature matching. Okay, so you are extracting the features. So for extracting the features also, you should be able to understand what is there. Okay, so for that also, this computer vision is used. Okay. And when you talk about these subdomains of computer vision, so everything is interrelated. Okay, so subdomains means where this computer vision can apply. Okay, so actually, this computer vision is a part of AI. Okay, it's a part of AI. That is where your cognitive computing again comes under your AI, and one part of cognitive computing is computer vision, and it has so many subdomains like scene reconstruction, again object detection, event detection, video tracking. Okay, then object recognition, Then 3D pose estimation. Okay, so that is this 3D vision or 3D imaging is very much useful now. Okay, so you are now you might be heard about this 3D printing and all. Okay, you can design and you can construct that. Okay, so in that also the main part is computer vision only. Okay, and yeah, that is this computer vision helps in learning. It helps in machine learning. Okay, and also in indexing, grouping, then most motion estimation. Say, for example, at what speed a particular object is moving. Normally, in the smart transportation, if a particular signal, okay, in a particular signal, some emergency vehicle is coming, okay, some ambulance is coming. So in that case, other vehicle has to give way to this particular ambulance, okay. And also, if you so in that case, it has to identify that. Object and in what speed it is coming. So so accordingly the traffic signal has to change. One more thing is if one lane is heavily crowded, okay, other lane is free. So in that there is no that is no vehicle. In that case, what you got normally when you see in the traffic signal, each signal, okay, so will be that for some 30 seconds or 1 minute, okay. Sometimes, so by default, they will fix like that. Okay, instead of fixing it statically, what you can do is through some video camera, you can identify the motion object, how many objects are moving, and based on the number of objects in one lane, if more number of vehicles are there, that corresponding signal you can make it green and you can allow them to go. Other signals you can block it. Okay, you can make it red. So like that, you can dynamically change dynamically. You can optimize that scheduling. Okay, so that people unnecessarily they need not wait. Okay, so it may sometimes cause traffic jam, etc. So that can be avoided. And the other one is this visual surveying. Okay, so what do you mean by this visual surveying is actually this is also known as vision-based robo control. Okay, this visual surveying is also called as vision-based robo control and abbreviated as VS. It's a technique which uses the feedback information extracted from the vision sensor to control the motion of the robo. Okay, so here actually this robo is moving. Okay, it's a machine. Okay, so it's moving. So how it is moving? Actually, we are trying to give the capability of vision to the robo, and based on that, it is moving. So you can take consider your Tesla car and all those things. Okay. So if there is any hindrance object, it changes direction and accordingly it moves. So that is actually this visual survey. And then 3D scene modeling, then image restoration. Sometimes image may be spoiled. Okay, you can do restoration. Okay, so that type of things also possible. So these are some of the sub domains of computer vision. Actually, it has a wide application as well as very interesting applications. Okay, so you can since you are in final year, you can think of all these areas. Okay. Think of all these domains. Okay, so all this application while you are doing your project. So nowadays, very frequently you are hearing about the flood, the rain, etc. So many people are isolated. Okay, so now using this drone technology, they are trying to identify the people those are isolated, and to them they provide help. Okay, so they provide food, medicine, etc. Okay. So in drone, what they are using camera. Okay, they are using drone cameras to identify and they can monitor, they can survey this flood affected area using this drone cameras. All these things are applications of computer vision. Okay, forest fire. Okay, so many forest is getting spoiled. Okay, because of this forest fire. So if you fix camera and if you are able to monitor that very early, it will be good. Similarly, the animals, okay, so they actually most of the time they move to the villages and spoil the agricultural land as well as they harm the people as well, right? So that has to be monitored so that it can be prevented. So many applications are there. You can identify some of the applications, real-time application, which has some societal impact. Okay. Similarly, as I have told you, it can be used in healthcare and it can be used in agricultural field. Okay, so in agriculture, so to monitor the crop growth. Okay, so to find out the that is soil condition. Okay, even though agri people they do soil test. Okay, through imaging also you can do all these things. Okay, so for pest control, everything can be done using this computer vision. So it is an important as well as an interesting area to do research. Okay, and so to implement this, there are a number of tools and languages that are available. So the best language for computer vision is C++. I hope now nobody is using this because you have to hard code everything. Okay, but mindlessly you can do that when you use C++. But the thing is, to read an image and to display an image itself, it will become a big, so you have to write number of codes. But nowadays we have so many tools are available in Python, in MATLAB. Okay, within a single command, actually you can easily read, write. You can do so many operations. So most of them, okay, are nowadays using this Python or MATLAB. Although it is made, its major drawback is that it is more difficult to achieve what you want. Okay, that is not what you want. Actually, it needs complicated codes. Okay, so that's the thing. Now most of them are using this OpenCV, so this is the best library for computer vision out there, and but you can do the same thing using a MATLAB or Python. Okay, so it is a real time. What is this OpenCV is? It is a real time computer vision library. So if any of you are interested in doing your project in this computer vision, you can explore all these tools and whichever you are comfortable with, whichever will suit your application, you can do that. Okay. So then TensorFlow, so it's a software library for machine learning, and using that, it also provides some methods and functions to read image and to process. Similarly, CUDA, okay, so that is NVIDIA's thing, okay. So parallel computing and programming, so it provides a platform because it occupies more space and computational complexity increases when you deal with image or video. Okay, because when you analyze a video, it has to be split into frames, and assume that you are taking a 1 hour video or something. In that case, it becomes a complex data set. Okay, so it needs a large amount of computing power as well as the storage power. So this CUDA provides a framework for parallel computing and programming. Okay, and also VisoShoot. Okay, so this is a no-code computer vision platform for business. Okay, so this also you can explore. Similarly, normally whenever we talk about imaging, what comes to our mind is MATLAB. Okay, because it has so many libraries and functionalities. But the main thing is it is a commercial software, so it is not available as open source. Okay, so that's the main drawback. Otherwise you can use this MATLAB. Okay, then Keras, so Python deep learning API. So that if your application, if your computer vision application involves, or if you have planned to do some deep learning architecture, if you plan to work with deep learning architecture, in that case you can think of Keras as well. Okay. But the main drawback or limitation of using images is when the image has surface geometry. Okay, understanding is very difficult. Okay, so it will not give an appropriate correct view when you go for the 2D images. Similarly, color inconsistency. Depending upon the lighting, okay, the color may vary. Okay, so that processing or analyzing those images at different coloring, different lighting effect may have a drawback. Okay, and this type of inconsistency may be there, and also weakness of monocular vision. See, for example, it may not able to understand the scale. Okay, how big it is, how small it is. So that type of things it may not able to understand. So when you see that pump, it's very huge, okay, but it may not able to understand whether it is big or small like that. And lack of texture, okay. So when you see this object, if there is no texture, in that case, retrieving the pattern or retrieving the shape or edge is very difficult in case of 2D images. Okay, so these are all the drawbacks or limitations of using 2D images in computer vision. And see here in this example again, if first thing whenever we wanted to identify some object, the first thing we do is you do the background elimination. Okay, you will remove the background. Okay, because we are interested only in that particular object. But here when you see this background and foreground have similarity, in that case it is very difficult to eliminate the background. Okay, so these are all some of the drawbacks of limitations of 2D images. So what is the potential solution? So how to overcome this limitations by 3D? Okay, so when you use this 3D object, 3D imaging, in that case, you can manage this. Okay, you can overcome this. So that we can discuss in the next class. So now I'll stop sharing. Now I'll call the people that I have mentioned, no, so to give their presentation. Okay, Naha Joshua, now you can present. You can share your screen and you can present.
Yes, ma'am. Ma'am, can you see? Ma'am, can you see the screen?
Yes, I'm able to see your screen.
Okay, ma'am.
Yes, yeah. Go to slideshow mode. Yeah.
Okay.
Then
Uh,
go to slideshow mode and then present. Slideshow.
I don't know.
Press F5 or in the menu there is a option called slideshow, right?
Yes, ma'am.
Click on that. Yes.
Okay. The things I have mentioned is only the like normal introduction between what is the computer vision and the human vision. Then the system of computer vision and applications and a little bit of examples. Then coming to the computer vision, it's a field of like where acquiring, processing, and analyzing and understanding images is done. And computer vision is also known as image analysis or scene analysis and image understanding. And so, computer vision can be also we have done it electronically to duplicate the human vision and the theory for building artificial systems that obtain information for images. So, and the image data can take many forms such as video sequences, depth images, and for multiple cameras and satellite sensors like that. And coming to computer vision versus human vision. So in human brain, so there are like most of the brain is devoted to vision particularly. And then coming to the vision is an amazing feat of natural intelligence. Then there are around 30,000 visual categories. Then if we an average man can learn around 4.5 categories per day, then it will take around 18 days to completely learn all the 30,000 visual categories. But at the age of 6 years, a child can learn all this 30,000 categories in just 13.5 days. So that is the difference between a human than a computer. So machines can't replicate this human image recognition when compared to humans. Then coming to why computer vision is difficult. So it is a many to one mapping. So there will the coding which we done to improve the computer vision is very difficult. Then it is also computationally intensive, and we do not understand the recognitive problem morely. Then coming to the system methods, then one is image acquirization, then pre-processing, future extraction, then segmentation or detection. Then the other one is recognition and interpretation. The applications of this computer vision are controlling process, navigation, detecting events, organizing information, modeling objects or environments, interaction, uh, and etc. Coming to the real life examples, that is optical character recognition. We can all see this type of things. Cameras can recognize the letters which we see in the camera, and then the login without a password, using your fingerprint or a face ID. This can be used, and in wars particularly, we use this target recognition to see the tankers of the enemies. Then the other one is interpretation of high resolution satellite images. This can be used for viewing satellite images for the wars and all, or else like to see the population and other things. Then the traffic monitoring. So this can be used. This is mostly used in other countries, as they have like different rules for the traffics. They mostly travel in one lines, so this will be used in most of the foreign countries. Then the face detection. This future we all know, when we try to use a camera like Google Lens or something. If a face is recognized, it will be seen the information of that particular person or something, or else like in particular cameras, autofocus is there. Like if a face is there inside a camera, so it will be automatically focusing on the face. Then coming to the other one is 3D shape reconstruction. So most of the buildings are before executing, they do this 3D shape reconstruction. So that the circumstances and the 3D model of the plan will be executed. And the other one is object recognition. As I told you before, if I take a picture of some of an object or something, like an important or famous thing, so it can detect that object, and it can show the details of that particular object. That's all, man.
Okay, no, okay, thank you. Good. So you have prepared well. Good.
Thank you. Thank you.
So the next person, next one. So in the first itself, I have told Nikita.
Yes, ma'am.
Yeah. So in assignment 5, that is components of deep architecture, I think only 2 have uploaded, Harshita and Rakesh. What about others? Yes, Ma, you can share and share your screen and you can present.
Okay.
Why attendance? Rakesh, attendance for today or
Yes, ma'am. Today only, ma'am.
why I
To
should
start,
be
there is no power in.
What happened?
There is no power in the house, ma'am.
No power. Where are you from?
Yes, ma'am.
Huh?
Andhra, ma'am.
Andhra.
Andhra, ma'am. Here some rain is happening, so that's why, ma'am.
Training.
Due to power short.
Okay, ma'am. Check.
Okay, ma'am. Thank you, ma'am.
Now is my screen visible?
Yes, ma'am. Yes, ma'am.
So my topic is about computer vision. It's about only the introduction. So first, as we all know, humans get their vision through eyes. So that we wanted to implement by using computers. That is called computer vision. So computer vision is basically viewing the images, I mean, three-dimensional images in the world with the help of two-dimensional images that is captured by television cameras. So since we all have two eyes and we look into images or objects with the help of those two eyes, we can use that with computer vision also, which is called stereopsis. That is by locating two different cameras at two different angles, so that the images are visible from various angles. So as we can see in this image, the tables are same since the view of the angle is from different directions. It seems like there are two different tables, but actually, if we measure, the table size is actually the same. But since the view and the angle is different, the both the tables look different. So the information that is uh, taken from those angles are one is about the lighting conditions, angles, the surface of the object which is being captured. So first there were few experiments regarding how the image is captured by uh, like few creatures. For example, first they tested with a frog. So they found that in the frog there are few detectors that respond to only certain kind of things. So, for example, it detected flies, which was moving and which was small. It detected flies. It had a separate detector for that, and there was one more detector for the lighting, the illumination, and that detector used to work for the illumination. And with that help of that, this was that they detected the frog's visual system, but the frog did not have actually a three-dimensional mode. It actually looked into the food or danger or object with the help of these detectors only. So then there was another experiment which was conducted uh, where they used certain neurons uh, in the mammalian visual cortex, and which is used to respond to only certain images or certain parts of specific shapes. There was another experiment where they implemented microelectrodes in the cortex of a cat. So after that, they found that the neurons were fired rapidly when images were shown like small lines in one angle, and when there was another angle when lines were shown, another set of neurons were fired. So based on these neurons which were fired, they were actually able to create a map of the cat's brain. That is, they separated the neurons as two types, that is simple cells and complex cells, and they distinguished based on the neurons that detected the lines in various angles. And there was another experiment which was conducted for recognizing faces. And so one experiment which they conducted, it was based on the coordinates of the features from the photographs. They used Graphicon or Run tablet, where it would extract the coordinates of features like center of the pupil, corner of the eyes, outside of the corner of the eyes, and so on. So from these coordinates, a set of 20 distances was computed, such as the width of the mouth and width of the eyes, and the distance from pupil to pupil. So these operators, like they processed about 40 pictures an hour, and then a database was built based on the features, and the name of the person of that feature was stored in the database, and the distance from the width of the eyes pupil to pupil was also stored in that database. And during the face recognition, uh, using all the set of distances was compared with the photograph, and closest result was returned. So there was an other experiment which was carried out. uh, for this he actually used a TV camera, and using that he tried to find the location of features such as eyes, nose, or shoulders in the picture. The hardest part was to do this using digital pictures, but he used a nearest neighbor method for identification of such images. So there was another person who did another experiment related to computer vision, where he ran this program on an assembler language, and it ran on a machine with 10 microsecond cycle and 20 KB of main memory. So he tested with about 1000 face images, which was during that time was a large scale experiment. Using 10 experiment was itself called a large experiment, but he tried it with 1000 face images. So on conclusion, face recognition programs had several limitations during the olden period, but now we have lots of technology that uh, helps in triggering the computer vision. The computer vision is basically an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. That's all, ma'am.
Okay, good, Nikita. So you have really done a good work. So you have actually analyzed. Okay, thank you. Thank you.
Okay.
Okay, so tomorrow, as I have said, the remaining people have to present. Okay, so I have called for some students now. So those people have to present in tomorrow's class, right? So tomorrow first class we have, for that.